I'm ready.
All right. So, the base angles theorem. If the legs are congruent, then the angles are congruent. This is an isosceles triangle. If two legs are congruent, then the bottom angles are congruent. It also works going backwards. If two angles are congruent, then the legs are congruent. That's what the if and only if means. What we're going to do is we are going to prove this theorem. We're going to prove it both ways. We're going to build the theorem so it goes forwards, and we're going to build the theorem so it goes backwards. So let's start with this right here. AB is congruent to AC. We have to prove that angle B is congruent to angle C, which is clearly what I wrote. We don't have enough information right now. Do you remember when we went out to the parking lot and we bisected the angles with the chalk and the string and everything? We bisected angles. We're going to do the same thing here. We're going to make it angle bisector. And we're going to say AD bisects angle BAC. This is also going to be given. Raise your hand, please. Give me one pair of things we can do to prove these triangles congruent. Ma'am?
AD is congruent to AD by reflexive.
Awesome. AD is congruent to AD by reflexive. Fantastic. We got that from the picture. That's pretty simple. We need one more thing. Yes, ma'am?
Angle BAD is congruent to angle CAD.
You are correct. BAD and CAD. We just bisected this angle. That's what this means. So angle BAD is congruent to angle CAD by definition of angle bisector. Now we have enough information to prove the triangle's congruent. What postulate allows us to prove the triangles are congruent? Yes, sir. Side angle side. Side angle side. Is the angle in between the congruent sides? Yes, it is. We've got sass. We don't have donkey. So we've got a side, we've got an angle, we've got a side. I'm going to bring these down together. Side angle side allows us to say triangle BAD is congruent to triangle CAD. And if the triangles are congruent, that means everything's congruent. So that lets us say angle B is congruent to angle C by definition of congruent triangles. Now, let's say you forgot, oh, what is that definition? I can't remember. You could just write, because the triangles are congruent. That also works. QED, we are done.
Don't forget the QED. It makes me angry when you forget the QED.
So, we have proven it going this way. We started with the sides being congruent. We proved the angles are congruent. Guess what? Now we got to go backwards. We got to start with the angles being congruent and show the sides are congruent. So let's do that one too. It's almost going to be the exact same thing. It's going to be really, really similar. This time, our given information is going to be angle B is congruent to angle C, and we have to prove AB is congruent to AC. We start with our given information. Now, of course, that alone is not enough to do it, so what do? We draw an angle bisector. AD bisects angle BAC. This is given. We made this. So, once again, let's do this. We got this. Give me a pair of things that are going to be congruent. Somebody new. Yes, sir. AD is congruent to AD. You are absolutely correct, sir. AD is congruent to AD by reflexive. Give me another pair of things that are congruent. You are giving me one. Yes, sir.
AB, AC.
That's what we're trying to prove. We can't use that theorem because we're making that theorem.
Okay, I got it now.
Go, all right.
Alright, AD. So hold on. Want to get those at the top there? You know the angles.
Yes. BAC is one being, this angle right here, BAC is being bisected, so we got the angle bisector right there. So what angles would be congruent, sir?
Angle BAD and angle CAD.
Awesomeness. Definition of angle bisector. Fantastic. So, this time we're not using SAS though, are we? What are we using? Well, this is a side, this is an angle, this is an angle. What are we using? Everybody shout it out. 1, 2, 3. Angle, angle, side. Side's not in between. So we're going to use angle, angle, side. Angle, angle, side. Angle, angle, side. Allows us to say triangle BAD is congruent to triangle CAD. But then, of course, if the triangles are congruent, that means everything's congruent. So that means AB is congruent to CD, not CD. AB is congruent to AC by definition of congruent triangles. Or, as the book likes to call it, CPCTC. And we are done. Now you may be saying, okay, Mr. Q, we proved it, so what? That's not going to help me on my homework tonight. Well, it will actually. But, let's do some example problems, shall we? What sort of problems are you going to see on your homework tonight? More importantly, how can we use this to actually figure things out? All right. Put an example up here. Leave the right side up for anybody who's still copying. Example problem. This is X, this is Y. This is, let's see here. We'll go with 40 degrees. This is 8. This is 8. How can we find X and Y? Think to yourself a moment. How many degrees are in a triangle? 180. So, sir, how can I find how many degrees is X and Y?
Take 180 minus 40 and divide that by 2.
180 minus 40 gives me 140. So you're saying that each of these angles is 140? No. What are you saying?
Then you divide that by 2
Well, why are we dividing that by 2?
because x is congruent to y.
Oh, these sides are congruent, which means these angles are congruent, aren't they? Which means y is the same thing as x. So we're just going to divide this by 2 and say each one is 70. We could also just set it up this way. X plus 40 equals 180. But then since we know that x is equal to y, we're good. So x equals 70, and y is also equal to 70. Pretty simple? Let's let's do one more, shall we? y minus 2, 10y, 3y plus 8, 40 degrees, 40 degrees means this is, we'll have you figure that one out. 2 degrees. Right off the bat, what do we notice? What do we notice? Yes, sir?
The two angles are congruent.
The two angles are congruent. What does that mean, sir?
Two sides are congruent.
What two sides?
The 5y minus 2 and 3y plus 8.
If they're congruent, then they're also equal. So these two sides have to be equal. Does that mean they have to equal this side as well? Nope, nope, not on this one. These two sides are going to be equal. So 5y minus 2 is equal to 3y plus 8. And we do a little bit of algebra from there. Subtract 3y from both sides. 2y minus 2 is equal to 8. Add 2 to both sides. 2y equals 10, so y is equal to 5. Y is equal to 5. Now, that's great. How many degrees is angle M going to be? Ma'am? 100. You are correct. It has to add up to 180 degrees. That's 100 degrees. Great. Now, Mr. Kuhne's going to ask you to classify this triangle by its sides and by its angles. What kind of triangle is this? Classify this triangle by sides and angles. Is it obtuse? Is it acute? Is it right? Is it equiangular? Is it scalene, isosceles, or equilateral? Yes, ma'am.
Obtuse, isosceles.
It is obtuse and it is isosceles. Long distance high five. Obtuse, because that's bigger than 90, and isosceles. Are any of these sides bigger than Mr. Kuhne's age? I'm 32. Any of these sides bigger than Mr. Kuhne's age? Which one?
10.
10y, yeah, because that's going to be 10 times 5, so this side's going to be 50. What about those sides? Are those going to be bigger than my age? No, 3 times 5 is, let's say, so that's going to be 15, 23, and 23. This is how we can use the base angles theorem. Tomorrow or Monday, we'll be looking at how it can be used in real life, how we can find things. Now, this is the base angles theorem. You proved this. The equilateral equiangular triangle theorem, you can prove this on your own for 10 extra credit points. You have to do kind of what we did for this one, where we're going to have to prove it both ways. You're going to say, given it's equilateral, you're going to have to do some stuff and prove it's equiangular. But then, we're going to go backwards. Say, given it's equiangular, you're going to prove that it's equilateral. We'll talk through it here just briefly. We'll do a ghetto proof of it, not a formal proof. But the proof of it's pretty simple. It's called a corollary. Corollary is something that just follows after easily. It's just going to kind of fall out of the bottom. So, triangle AB, given that triangle ABC is equilateral. Everybody, what does it mean if it's equilateral? Say it out loud. Go.
Same side.
All sides are congruent. Now, we can use the base angles theorem right here. If the two sides are congruent, what does that mean?
The angle.
The angles are congruent. But wait, these two sides are also congruent. So this angle is congruent to this one. Well, that means they're all congruent, doesn't it? And if they're all congruent, that means it's equiangular. Easy? You see how it just kind of falls out like, oh, yeah, duh. Do these prove triangles congruent? No. Side angle side does that. Angle angle side, side side side, and angle side angle. These don't prove triangles congruent. It's just one step in there. You notice we're only talking about one triangle in each one of these. Now it might be used as a step in getting to side angle side, but by themselves they don't prove triangles congruent. The last one here, the hypotenuse leg theorem. This is the actual case where angle side side does work. Remember how I said angle side side doesn't work, it's a donkey? This is the one case where it does work. Because I got a pair of angles, I got a pair of sides, I got a pair of sides. Those triangles are always going to be congruent. But we don't call it angle side side. We call it hypotenuse leg theorem because the angles have to be right. This will result in two triangles being congruent. So this is one more weapon we have to prove triangles congruent. Big ideas here today. Base angles theorem. Two sides are congruent, then the two angles are congruent. We already learned this at the beginning of the chapter, but now you know why. Now you know that there's 180 degrees in a triangle. There's a lot more cool things we can do with it. Your homework tonight is page 289, numbers 1 through 7. Page 252, numbers 31 and 38. You only have 9 problems for homework tonight. Not extremely tough. I'll be passing out the homework quiz you took yesterday. And we will also watch the parallel lines video today. Only if you are working on the homework when you're working on the homework and not just sitting around dawdling.